Numbers, page 7. Write these numbers correct to two significant figures. So 355, I would want to keep these first two figures as the significant figures. So I'm going to throw away this one here, replace it with a 0. Now, am I going to make the 5, am I going to make that a 5 or a 6? Well, the next number is a 5, so I'm going to make that a 6. And then the 5 is replaced with a 0, so I have two significant figures. For this one, the two significant figures are these two, okay, the first two. The 1, is that going to round the 0 up? No, it's not. So we're just going to put 8, 0, and then we cut it off. We leave out the 1, and we don't need to replace the 1 with the 0 because it doesn't change the value of whether having that 0 or not, okay? So since we only want two significant figures, we need to erase that one. Do you see how this 0 here, it's not a significant figure. It's only keeping the 360 from becoming a 36, okay, because it separates the 0 from the decimal point. 1.075, so we want to keep these two significant figures, the first two. The 7 is going to round the 0 up to a 1, right? So it's going to be 1.1, and the rest of them we just ignore, okay? And we don't need to put them there because it's not going to change the value if we don't. We want to keep 1 and 5. Now, is the 6 going to make the 5 round up to a 6? Yes, it is. And then the rest of them we just replace with zeros, okay? These are significant figures. The zeros are not. The zeros are just there to make sure that the 16 or the 1600 stays 1600 and doesn't become 16. Three significant figures. So let's keep the 2, the 9, and the 7. Is the 1 going to cause the 7 to round up to an 8? No. So 297, and then we're going to replace the 1 with a 0. Three significant figures. Three significant figures here. We're going to keep the 3, 2, 5. Is the 9 going to cause the 5 to round up? Yes, it's going to round up to a 6. And then we just discard the 9, right? So it's just 0.326. Here we're going to keep 104 and we're going to throw away the 10. Is the 1 going to cause the 4 to round up to a 5? No. Okay. 500. So these first three digits, we're going to keep those. Does the 6 cause this next 0 to round up to a 1? Yes, it does. So it's 0.501. Okay, it says calculate this expression here. We're going to put it in the calculator. Again, putting the numerator and the denominator in parentheses helps make sure that we're not going to have any PEMDAS problems. So we're going to have square root 8.7 plus 2 times 1.6. Okay, and that's in parentheses. And then we divide, and then in parentheses we put, 0.3 to the fourth. Okay, so the answer is 425,881,929. 425.8811,929. Okay. Give your answer correct to one significant figure. So we just want that. So it would be, would the 2 cause the 4 to round up to a 5? No, so it would just be 400. Okay? Three significant figures. Then we're going to keep 425. Does the next number 8 cause the 5 round up to a 6? Yes, it does. One decimal place. So we want to keep all the numbers left of the decimal point, and we want to keep the first number of the decimal. So it would be 425.9. Because the next number, 8, will cause the first decimal place number 8 to round up to a 9. The nearest hundredth. Remember, hundredth, let's see, this is tenth, this is a hundredth. So we would want to keep 425.88. And then what about the second 8? Is the second 8 going to round up to a 9? No, because the next number is just a 1, so that's not enough to make it round up. Okay. Write the value of pi correct to the nearest unit. Remember, pi, the first few digits of pi are 3.14159 to the nearest unit. So the nearest unit would be the 3 here. So is it closer to 3 or 4? It's closer to 3. 2 decimal places. So let's see. 2 decimal places would be the 1 and the 4. Now, is the next number 1 enough to round the 4 up to a 5? No. This is usually what we typically see for pi, right? 3.14. 2 significant figures. So that would be the 3 and the 1. Is the 4 enough to round the 1 up to a 2? No. 3.1 is where we're going to stop. 3 decimal places. So that would be the 1, the 4, the 1, and then the 5 we're not going to take, but is the 5 enough to round the second one up to a 2? And yes, it is, right? So 3.142. Write down these numbers to the accuracy stated. 238. One significant figure would be the 2 here. So we're going to keep the 2, and then is the 3 enough to round the 2 up to a 3? No. So we replace the 3 and the 8 with just zeros to make sure that the 200 stays 200 and doesn't become 2. 3 significant figures. So we're going to keep the 4, the 6, and the 0. Is the 9 enough to round the 0 up to a 1? Yes, it is. So we're going to put 461, or that's 4,610. Okay? Next one, 3 significant figures. So we're going to keep the 2.70. What about the next 0? Is that enough to round the last 0 up to 1? No. But we are going to keep the last 0 here. That is significant. Okay, now we're going to calculate one more expression here. Cube root of 3.375 divided by 1.5 squared plus 1.8. Remember, we do want to put both the top and the bottom in parentheses, because whenever you have the horizontal fraction line, that's what that implies. So we're going to put cube root. There's a couple ways to do cube root. The fancy way is to go into math. Oops. And then we click on that, cube root. And inside the cube root, we're going to 3.375. Oops. Okay. Now, parentheses, divided by, parentheses, 1.5 squared plus 1.8. And the answer is 0.370, repeating. The full, it says write down the full calculator display. So 0.370, 370, 370, 4. Okay. Then it says, give your answer to part A correct to 2 significant figures. 2 significant figures would just be the first 0.37. Is the next number 0 enough to round the 7 up to an 8? No, it's not. So we leave 0.37. 3 significant figures would be the first 3, would be 0.370. Is the next 3 enough to round the 0 up to 1? No, it's not. 4 significant figures. We're going to keep 0.3703. Now, is the next number 7 enough to round the 3 up to a 4? Yeah, it is. So we're going to erase that 3 and we're going to put 4. Okay? That was number 8. 1J1. The area of a circle is 10.5 centimeters squared. Find the length of its radius. Give your answer correct to 4 significant figures. Find the length of its radius of a circle with 10.5 centimeters squared. Okay, so Remember that the formula for the area of a circle is area equals pi r squared. So the area is 10.5 centimeters squared. It's equal to pi r squared. I'm going to find the length of the radius. I can find that by doing a little bit of algebra here. So I'm going to divide both sides by pi, and then I'm going to get r squared equals 10.5 pi. And then I'm going to take the square root of that, 10.5 divided by pi, square root of everything. And then I'm going to get a number with a lot of digits. So let's do that. So it's going to be square root 10.5 divided by pi. .828, etc. So I'm going to write it to 4 significant figures. So 1.828, that's 4 significant figures. The next number is 1. Is that enough to round the 8 up to a 9? No, so we just stop there. Find the length of its circumference. So this is part B. Give your answer correct to 2 significant figures. Just going to make this a little bit smaller so we have more room. Okay, B. Find the length of its circumference. So that would be circumference equals 2 pi r. Okay. We know that r is 1.828. So we're going to have circumference equals 2 pi times 1.828. And we'll multiply that out. 2 times pi times 1.828, 11 point, and we're going to give 2 significant figures, so we just keep the 11, and the 4 is not enough to round the 11 to a 12, so we just put 11. It says, do not forget to write the units to your answers. So this would be centimeters, and this would be also centimeters. Okay. Last one on this page. Let the numbers p equals square root of 2 and q equals square root of 10. Find the arithmetic mean of p and q. Give your answer correct to 4 significant figures. So remember, the way you find the mean is you add all the numbers up, and then you divide by the total number of numbers. So this is going to be, let's see, and I'm going to put parentheses around both the numerator and the denominator just to make sure the PEMDAS is respected. Square root of 2 plus square root of 10. Oops. Divided by 2. 2.28 blah blah blah. I want to keep 4 significant figures, so that would be 2.288, and the last 2 is not enough to round the 8 up to a 9, so it's 2.288. 2.288. Okay, find the value of p plus q quantity squared. Give your answer correct to 3 significant figures. Okay, so p plus q quantity squared. So that would be square root of 2 plus square root of 10 squared. Okay, so let's see what that is. We can just, like, instead of typing that all in, we could, like, take advantage of this part that we already typed in. Square root of 2 plus square root of 10 is squared is 20.944, etc. Give your answer correct to the first 3 significant figures, so we want 20.9. This 4 is not enough to round the 9 up to a 0, so we just keep 20.9. That was B. C. Find the area of a rectangle whose sides are P and Q long, Give your answer correct to two significant figures. Find the area of a rectangle whose sides are P and Q long. Give your answer correct to two significant figures. So we have a rectangle. Square root of 2, square root of 10 are the sides. To find the area, it's equal to square root of 2 times the square root of 10. Okay, so we have square root of 2 times square root of 10. It's so awkward to type things here. I'm just going to... Okay, square root of 2 times square root of 10. It's going to be 4.47 blah, blah, blah. Give your answer correct to two significant figures. So it would be 4.4. Now, is the 7 enough to round the 4 up to a 5? Yes, so it's going to be 4.5. Okay, so that is part C. All right, and that is the end of page 7.